Okay, welcome everybody to the November 2019 Soils Network of Knowledge webinar. It's on the Fertcare Soil Sampling Guidelines. They're going to be presented by Dave Weaver and Jeff Clark, and it's brought to you by New South Wales DPI Soils Unit. Now I'd like to introduce Jeff Clark, who's helped along with Dave Weaver, who is presenting today's webinar on new Fertcare Soil Sampling Guidelines. Jeff grew up on a farm in Bundaberg in Queensland and followed his interest in soils and plants by studying at the Queensland Agricultural College. Jeff has a long history in the Australian fertiliser industry in a range of sales, marketing and technical support roles. A large proportion of his professional life was spent with Incitec. Having worked across much of Eastern Australia, Jeff has had exposure to industries such as sugarcane, horticulture, grains and intensive pasture. Jeff is now part of Fertiliser Australia. His main area of responsibility is to manage the industry's environment and food safety stewardship program, Fertcare.
Well, thanks Luke and Abby for the opportunity to contribute to the Soil Network of Knowledge webinar series. Good afternoon or good morning to everyone, depending on which part of Australia you are. I want to make a few introductory comments, and Dave Weaver, a colleague in the Department of Agriculture in Western Australia, he'll go through some of the detail of the Fertcare Soil Sampling Guide. So just briefly, I want to touch on evidence-based fertiliser recommendations and why that might be important. I want to talk about some of the changes in the Fertcare performance standards that are coming up, and then Dave will dig into the soil sampling guide in a bit of depth and unpack some of that for you. So the soil and plant nutrition recommendation approach that Fertcare endorses is to use objective measures such as soil or plant testing, appropriate analysis and interpretation methods to arrive at evidence-based, site-specific nutrient management plans at a paddock level. The basic premise being to match the crop nutrient demand with the nutrient available from the soil or applied fertiliser or other nutrient sources such as animal manures or, in the sugarcane industry, mill mud. So look, it's a simple concept, but somewhat more challenging to actually implement. So why would we bother with evidence-based fertiliser recommendations? You know, as a professional providing soil and plant nutrition advice, wouldn't historical practice be okay, or rules of thumb? I want to suggest that there's two main reasons why evidence-based fertiliser recommendations are really important. And the first one is trust. Trust between your farmer customer and yourself is built through the ethical provision of advice, which is demonstrated by basing the soil and plant nutrition advice on objective measures such as soil and plant tissue testing. The other one is that as agriculture and its off-site impacts on water quality and greenhouse gas emissions comes under increasing public scrutiny, basing fertiliser recommendations on a body of evidence that can be defended from a science perspective will be one of the factors that will help the industry strengthen its social licence to operate. So, as many of you would be aware, soils are inherently variable, and this variability results from, the soil parent material, the topography, climate, hydrology, weathering processes, and biological processes. Variability can occur horizontally and vertically. Variability can be caused by animals or tillage, drainage issues, crop removal, soil amendments and fertilisers. So the importance of accurately collecting and representing a sample is highlighted by the fact that the dispatched sample to the laboratory represents a very small proportion of the field being assessed. So depending on the area of the field and the depth to which you're sampling, there can be thousands of tonnes, easily thousands of tonnes of soil which are in the field. We collect a small portion of that through our sampling process, maybe 1 to 3 kilos. We send 500 grams to the lab, and the laboratory might analyse 10 grams. So it's a very small proportion. Collecting soil samples which accurately represent the plant soil environment is fundamental to evidence-based fertiliser recommendations. We have to get this part of the process right. Dave Weaver from the Western Australian Department of Primary Industries and Regional Development, and Cameron Gooley from Agriculture Victoria Research agreed to review the Fertcare soil sampling notes. And so after input from other researchers and practitioners, we've got the updated and revised Fertcare soil sampling guidelines. And these guidelines have been endorsed by ASPAC, the ASPAC Fertcare Technical Committee. So you can be confident that the information in this has got broad support from people with a detailed understanding of the science, but also from a practitioner's perspective as well. For those of you that have taken the time to read the guide, you'll know that there's a few pages involved, and we are planning to provide some short industry-specific soil sampling guidelines in the future, and we'll be seeking your feedback on the best medium to communicate these industry-specific short summaries at the end of the webinar. So please provide your feedback on that in due time. I want to change tack just a little bit and talk about the Fertcare Accredited Advisor Performance Standards. The performance standards describe what is expected of accredited advisors. In other words, it provides, as it were, the minimum standard for the provision of soil and plant nutrition advice to farmers. You might recall that the performance standards cover 5 key areas: that of sampling, analysis, interpretation, recommendation, and monitoring. The Fertcare performance standards are what Fertcare approved auditors are comparing against when they review a sample of your recommendations if you're a Fertcare accredited advisor. So as a result of a recent review, the ASPAC Fertcare Committee have endorsed a few changes to the performance standards. And just to summarise those standards quickly, the first one relates directly to the Fertcare Soil Sampling Guide. So the sampling approach that Fertcare accredited advisors are expected to adopt must adhere to the Fertcare Soil Sampling Guide. The sampling approach must be described as part of the recommendation report. So here we're looking for a greater level of transparency, about the sampling approach. Historically, many of you would have put the sampling depth, which is great, and we want to continue to encourage that. But we also want to encourage you to describe the sampling approach that you used as the basis for the recommendation. So, for example, did you use a cluster form of sampling, or a transect, or a grid sample, or just being a little more transparent about the sampling approach that was used is expected in the future. The sampling locations to be recorded by GPS coordinates. So recording should include individual sampling transect or cluster locations that make up the composite sample. So sampling apps such as Decipher or FarmLab or Farm2 Lab or LabStream, these are just some of the examples of tools that are out there. They can make this process simple. So we'll be seeking your feedback on this also at the end of the webinar. We've also had a bit of comment about if you've got a farmer customer that might be a bit sensitive about recording the exact location of sampling purposes from a privacy perspective. If you're a Fertcare accredited advisor, you just need to make a note of that if that actually occurs for you. The final change is that evidence used as a basis of revising a system-generated nutrient recommendation needs to be documented and available for external review. So if you're a user of a Fertcare assessed system, such as New Logic or SoilMate or Nutrient Advantage, if you choose to modify the system generated nutrient rate, you need to keep some notes about why you did this and the basis for that change. So these 4 changes to the Fertcare Accredited Advisor Performance Standards come into effect from December this year, so next month. This webinar on the soil sampling guide is extremely timely in that respect. Let me now, that wraps up basically what I wanted to say. I'll pass over to Dave Weaver to outline some of the key areas in the Fertcare Fit for Purpose Soil Sampling Guide. But for those of you that don't know Dave, Dave is the Principal Research Scientist in Nutrient Management with the Department of Primary Industries and Regional Development. He's based in Albany in Western Australia. Dave's got 37 years of experience in nutrient management, particularly undertaking research into practices to manage the loss of phosphorus from agricultural landscapes to waterways. Dave's expertise includes the use of best management practices to manage phosphorus loss, soil testing, and whole farm nutrient mapping to support fertiliser decisions. He's also been involved in farm and catchment nutrient stocks, assessing those, the flows and transformation. He's been involved in effluent and riparian management, got a long history in pasture trial research and modelling the outcomes of nutrient management practices at a catchment scale. So we're very grateful to have the expertise of Dave and Cameron in developing the guide, but more specifically Dave today in presenting a bit of detail around that. So over to you, Dave.
Thanks, Jeff. Thanks very much, Luke, Abby, and Jeff for that introduction. And I'll be presenting some of the aspects of the Fit for Purpose Soil Sampling Guide on behalf of myself and also Cameron Gooley. So what I want to do in this presentation is I want cover a bit of background and context first, just to reinforce, I guess, some of the points that Jeff's already made around the importance of soil testing. And then we'll get into the Fit for Purpose Soil Sampling Guide itself and have a look at a number of aspects of the guide, including things like, the purpose for taking soil samples, what you might consider around collecting a representative sample, understanding a bit more around variability, what sort of sampling strategies and patterns you might think about employing when you're undertaking soil sampling, collecting the right number of cores, considering things like soil sampling depth, issues around fertiliser banding and how that influences what you might do. The collection of geocoordinates, as Jeff's already mentioned. And I'll talk a little bit about soil testing to understand nutrient loss pathways in comparison to what you might normally do for agronomic tests. We'll touch a bit on sampling tools, handling and hygiene, and do a little bit of a summary. So just in terms of a bit of background, it's really important to recognise how important agriculture is to Australia, and that it accounts for about 4% of GDP, a lot of our export earnings, and something like 400 million hectares of farming land across the country, of which about 50 million hectares is arable. And that's mainly around cropping and improved pastures. And in terms of the value of some of those industries, cattle's worth about 9 billion, We've got cropping's worth about 7 billion, dairy's worth about 2.5 billion, and the sugarcane industry is about 1.3 billion. So, you know, there's a lot of agricultural land there to manage, and that agriculture is important to income and jobs around the country. And when we think about things like the nutrients that are used to support those agricultural enterprises, there's significant use of nitrogen, currently at around 1.5 million tonnes per annum, phosphorus at around 0.4 million tonnes per annum, potassium around 0.2 million tonnes per annum, and our annual expenditure on those nutrients is in the order of $3 billion. And probably about 60% of that expenditure is in grains, about 25% in grazing, around about 8% in fruit and vegetables, and about 7% in sugarcane. So there's a significant investment in supporting agricultural enterprises, and as Jeff's already mentioned, that you would hope that that investment is based on objective evidence. So along with that nutrient use, there are also significant nutrient problems around the country, mostly around the coastal areas of the country. So in the west, for example, we have various water quality and algal bloom issues, fish kills, etc., that occur in and around the Swan Canning, the Peel Harvey, the Vass Wonnerup wetlands, around Geograph Bay, around the Albany harbours from where I am. And on the eastern seaboard, there's issues, as you would know, around the Great Barrier Reef with both sediment and nutrient loss. And again, on the eastern seaboard of the Murray-Darling, issues with algal blooms associated with nutrient delivery to those systems. So those sorts of issues are often associated with agricultural development and the fertiliser use and nutrient inputs that go in to support that agricultural development. And I just wanted to touch on an example here from the West, which clearly identifies from both monitoring and modelling that agriculture is the main contributor of nutrients to these systems under threat. So the size of each of the pies that you see in that diagram there represents the average annual tonnage of phosphorus being discharged to each of those systems. As we get into more populated areas, we find the proportion that comes from the urban sector tends to increase. But a lot of these nutrients are derived from diffuse sources, so stock, so that's nutrients that are stored in the soil, given that agriculture has been carried out in the landscape for half a century or more. Some of that may be directly from fertiliser or from the land application of effluent, and occasionally it may come from point sources like direct effluent discharge. So it is really important that we manage agriculture and we manage our nutrient use in agriculture in as an objective way as we possibly can. And Jeff's already touched on this around the importance of evidence-based fertiliser recommendations, trusted advice, and maintaining community support for the farming sector or social licence. And he's mentioned also, Fertcare accredited advisors, and the fact that there's 5 key areas or competencies or performance standards that Fertcare advisors need to adhere to. And they're soil sampling, analysis, interpretation, recommendation, and monitoring. And all of those aspects are consistent with the 4 R's nutrient stewardship goals of the right source of nutrients in the right rate and the right time and in the right place. And I think it's really important to recognise right up front that this whole exercise is underpinned by soil sampling and good soil sampling. And the other thing that's really important to recognise as part of this process is that the sampling component of this cycle of activities costs, the sampling component costs about 30% of the total cost of a soil test. So it's really worthwhile investing good time and thought around the sampling process and how we might get that right. Again, Jeff's already touched on this, that, you know, the whole activity of sampling, analysis, interpretation, and recommendation is based on a sample that needs to be representative, given that, you know, really quite a small proportion of what we collect in the paddock is actually delivered finally to the laboratory for analysis. And for some particular analytes, whilst you might you know, be using 5 to 10 grams to do some analyses might be half a gram or, you know, even a gram. So, you know, when you've got that kind of level of subsampling from starting with potentially 1,300 tonnes of soil in the 0 to 10 centimetre layer in a paddock or a block or a zone, and that's distilled down to 1 gram in the laboratory, then getting as representative a sample as possible is really important to everything that follows on from that sample. So, you know, if we don't get that right, you know, we may not have meaningful analysis in the lab, we may not have meaningful interpretation, and we may not have meaningful recommendations. So poor sampling could lead to a poor recommendation. Jeff's already also mentioned, I guess, that, you know, as part of one of these competencies, the use of appropriate laboratories to make sure that the sample that you've collected is analysed to appropriate standards, and the ASPAC, or Australian Soil and Plant Analysis Council, is the vehicle for ensuring that laboratories are involved in various proficiency programs to test their competency in doing particular types of analyses. And you can go to the ASPAC website and you can look for laboratories that you might be choosing to submit samples to, and you can see how competent they are in undertaking analyses for particular analytes. So you can search by analyte and you can search by laboratory, but it's important that you go to the website, have a look and see if the laboratory that you tend to use is listed and what they have competencies for. So when we move on from, you know, our soil test, we've then had it analysed in an ASPAC accredited laboratory. We then need a good interpretation of that soil sample and the numbers that come back. And there's been some large national programs that have resulted in significant publications that describe those interpretation standards. So 2 of those would be the Better Fertiliser Decisions for Cropping program and the Better Fertiliser Decisions for Pastures program. And those particular programs have involved hundreds of trials, thousands of experimental site years worth of work, tens of thousands of pasture or crop growth measurements, and national science networks of people involving government, industry and researchers to essentially collect all of that information together to come up with the best available peer-reviewed science and to provide standards that the industry can use to evaluate the soil test data once it comes back from laboratory. So as a bit of an example, this is some figures that have come out of a recently published paper as part of the Better Fertiliser Decisions for Pastures work. So it's in Crop and Pasture Science, Gooley et al., just been published in the last month or so. But what you'll find in that publication is representations of the response functions and the critical values that have been derived from these national collections of data. So for example, you'll see that for things like Olsen P on the left-hand graph. In the middle set of graphs, you see phosphorus buffering index dependent coal oil phosphorus values. You'll also see things like texture dependent coal oil potassium values and sulfur critical values as well. And look, I guess, you know, despite having these standards, interpretation against those standards can be influenced by having a poor soil test. So a good soil test underpins this whole process of analysis, interpretation, and recommendation. I now want to have a bit of a look at a bit of data that has been amalgamated from around Australia, and the value of soil testing becomes even more evident when you explore this sort of soil test data from around the country and you assess this soil test data against these standards. And you consider what this soil test data tells you, both in a general sense about constraints that you might be facing out there generally and environmental risks that you might be facing there generally. So this chart that we have here on the right-hand side that you can see now is showing you on the x-axis an index, a phosphorus fertility index, and it basically aggregates or amalgamates Olsen and coal oil P data across states onto a common scale called the phosphorus fertility index. And on the y-axis is what we have is the cumulative proportion. So anything that's in this grey area in this chart is showing you where there might be production concerns. So in other words, where the phosphorus levels are below the particular standard that we're interested in, which in this case is a phosphorus fertility index of 1, which is what our target is. And anything to the right of that value is in excess and where there might be environmental concerns. And right on this value of 1 here is where we have sufficient phosphorus in the soil. And as we move up this scale to a value of 2, we've got twice as much phosphorus in the soil, or up to 5 times as much phosphorus in the soil. But what's important on this chart is to recognise that in pretty much all states, greater than 60% of all of the sampled soils don't appear to be constrained by phosphorus. And in fact, then if we have a look at the chart on the left-hand side, which is looking at similar sort of data but in a slightly different way, we can see for this example in the Peel-Harvey catchment that we have a lot of phosphorus sufficiency, a lot of sulfur sufficiency, but there's a lot of constraints from potassium and from soil acidity. So, we can see that, as we move into these areas where we have more phosphorus in the soil than we require, we're increasing economic risks to growers, particularly if We're recommending nutrients when perhaps they don't need it. We're increasing environmental risk by way of water quality and other issues associated with water quality and the loss of nutrients. And we're also increasing threats to social license. The bottom line, I guess, with this is that you don't really know where you're operating without having a soil test in the first place. So now let's get stuck into the guide itself and a bit more detail on the why, when, where and how of soil sampling. So what I want to cover here is some aspects around defining the purpose of soil sampling. Accounting for things like soil type and management might be important. Thinking about the strategies that you might use for your soil sampling approach. Identifying representative zones or paddocks or areas and taking representative samples within those. What might be an appropriate sampling pattern that you would choose? How do we work out, how many cores we should take? We'll touch on some of the soil sampling tools, the right depth, and some documenting and recording. So let's start with the purpose for soil sampling. And I think it's really important to reflect on this particular question here is, what is the question the client wants answered? If you don't know, don't sample until you do. And there's really a number of reasons why you might be soil sampling. So one of those is diagnostic. This is a fairly kind of reactive type of strategy, and what you might do in this particular instance is be asking yourself whether particular analytes are causing spatial differences in the crop. So you might have good and poor performing areas in the crop, and you might stratify your sampling and take samples within areas where there's poor performance and take samples within areas where there's good performance and try and understand the differences between those two. Probably one of the most common purposes for sampling is predictive. So this is where you're taking a sample to support a fertiliser recommendation or some sort of nutrient amendment such as lime or gypsum, and you're wanting to work out, well, how much of this particular nutrient or amendment do I need? And you would be using the guidelines or critical values that I mentioned earlier from Better Fertiliser Decisions for pastures or crops to come to that decision. A third reason may be monitoring, in that you're wanting to determine whether particular nutrients or analytes, might be pH or something else in the soil, how these things are changing over time and whether they're changing according to management practices that are being put in place. And I guess the last one is increasingly compliance. So, are there regulations that prescribe sampling requirements? Are you in an environmentally sensitive catchment? And certainly for places like the Barrier Reef, there's some guidelines around taking soil samples in those particular catchments associated with the Great Barrier Reef. So there may be compliance or environmental and human health standard reasons for taking samples. So let's move on to when to sample. Well, clearly, one thing that's really important to consider here is to allow enough time between the sampling, analysis and interpretation and making a recommendation. So you've got to do that well in advance. And quite often that's about, I guess 4 weeks in advance of when a recommendation might be being made. Also, if you're looking to assess the effect of some sort of treatment, you may have to sample well in advance of wanting to see those treatment effects, and there may be, a 3 to 4 month window to account for those sorts of effects to take place. It's also really important in terms of timing that you take samples prior to fertiliser or soil amendment application. If you don't, it can really influence your sampling strategy, the number of cores that you might need to take, and introduces significant variability that you need to take account of. So prior to fertilisation is very important. If you're faced with a situation where fertiliser or soil amendments have been applied, you're probably going to have to wait for several months after those applications before you undertake sampling to ensure that the nutrients from the fertiliser or effects from those soil amendments have taken place before you take your sample. And often the timing of sampling is population research. So for example, if we think back to the Better Fertiliser Decisions for Crops or Pastures work, there may be other local calibration research which basically dictates that soil samples are taken in summer because the pasture or crop responses were evaluated in the following winter. So when we think about now moving on to things like sampling strategies and sampling within the farm, there's a number of possible strategies or approaches that you might consider. So the first of those, and it's probably the preferred approach, but probably the most labour intensive and costly approach, is to undertake complete monitoring, where you essentially soil sample every paddock or block or zone every year around the farm. So you get quite comprehensive information this way, but you do have to offset that by considering the cost in terms of labour, the cost of the analysis, but you may get the best returns from that as well. Another option that people often use is to move around the farm, or what we call cycling, where in this particular example, you can see the graphic on the left-hand side there, where you might do a third of the farm each year. So you might do the blue locations one year, you might do the red locations another year, and you might do the green locations in the third year. So you've essentially cycled around the farm in 3 or 4 years. Another approach that's used is to take a representative sample. And this is certainly strongly advocated in the dairy industry, where you might identify what's known as a typical or a representative paddock within a zone, and you take a sample within that typical or representative paddock to make fertiliser decisions for the rest of the paddocks within that particular zone. Another potential approach that is used is what we term here as uniform spread, where samples are bulked across a number of paddocks within a zone. But I guess this does introduce some significant issues in that you're going across areas where you're introducing areas where there's potentially more variability. The other thing that's really important to think about when sampling within the farm is to, wherever possible, to start off with some really good base maps. So that would be things like paddock boundaries and also soil testing boundaries. And you can overlay those and identify whether there's particular elements within those overlays that can assist you with your sampling strategy. So if we now have a look at looking at, say, a particular paddock and how we might sample that particular paddock, we've got 4 examples here. The first example on the right-hand graphic there is where we might have a uniform soil type right across the paddock, and we could quite easily take a composite sample within that paddock. If we have a situation where we have multiple soil types within a paddock or a block, then we might consider taking samples within each of those soil types. If we had a consistent soil type across the paddock, but we had some different land management within that particular paddock, we might consider stratifying according to that land management. In this case, it might be beef cattle in one half and it might be canola crop in the other half. And we would consider taking separate soil samples within each of those zones. Or we might have a situation where we have a combination of both soil types and management. And the ideal approach here would be to take a soil sample in each of the zones identified in that bottom right-hand graphic there. So you would take a soil sample in zone A, another one in zone B, one in zone C, one in zone D, and one in zone E. But we do have to be mindful here that farmers don't necessarily manage their paddocks according to these strata, and quite often they'll manage the paddock uniformly. And if you're making a fertiliser recommendation, the farmer is not going to change his fertiliser program according to the strata that you've identified, then it may be more pragmatic for you to sample the dominant soil type within a particular paddock and adjust the fertiliser recommendation accordingly. What's probably really important here, though, is that there's a conversation had with the grower in order to identify where the best place is for sampling. So variability, understanding variability is really important, as Jeff's already mentioned. Here we can see a map that's showing soil phosphorus status classified as high, medium or low across a particular farm. And you can see how that varies across the farm. Whilst you might get that sort of variability across the farm, if you look more closely within a paddock, and this is some work done by Bill Koching, it identifies that you can have significant variability within a paddock, and you can tend to have high nutrient areas around gates and high nutrient areas around troughs. So understanding that is important. And when you think about that and you're out there sampling, there's some things that you can actually see, areas that you might need to avoid, such as being close to fence lines, near gates, near stock camps, feed trails and stock tracks. But potentially there's other atypical areas that you may not be able to see, such as old fertiliser or lime dumps, timber burns, headlands, urine and dung patches. So some things you can be aware of quite easily, other things you won't be able to see. But accounting for whatever variability is there is very important, and that means getting good coverage of a paddock or zone with the appropriate number of cores. So how many cores should be collected? This is some summary information here from the fit for purpose soil sampling guide. And on average, when you're looking for plus or minus 15% area error in a field with average variability, you'd be looking for 30 to 40 cores if you're taking a standard pogo of 19 millimeters in diameter, or 20 to 30 cores if you had a 25 millimeter diameter pogo. And this information is based very much in statistical theory, and basically what we're showing here is the representation of that statistical theory and how it applies to your sampling strategy in relation to the number of cores that you want to collect. So what we have on the x-axis in this diagram is how close you want to be to the true value, and we've adopted about a 15% error here. And you want to be, say, 95% confident that you're within 15% of the mean value, would mean that you'd probably need to take around 30 to 40 cores. So unfortunately, the statistical theory states that as you have more and more variability, you need to take more and more cores. And usually as we're collecting samples, we're collecting one sample for a range of different analytes, and the analytes do not all have the same amount of variability. So we're usually collecting the number of samples to account for the analyte with the most variability. So if we're going for something with, say, an average variability of, say, 50% coefficient of variation, then we need to take around 30 to 40 cores to cover off on that variability. There's a number of sampling patterns that you might consider to use, and those sampling patterns have a range of attributes. But what we're showing here is some common patterns that are used. So transect, zigzag, cluster, a uniform grid, or random sampling. But in each of these cases, we're careful to avoid areas such as within 10 to 20 metres of fence lines, keeping away from gates and troughs. Some of these patterns are easier to use than others, in that, for example, things like transects are potentially much more repeatable than things like a random type approach. It's usually quite labour efficient in that you're often going in one gate and out another gate in the other corner of the paddock. It's likely to be relatively easy to automate in terms of the fact that if you're collecting geocoordinates, you could follow that transect relatively easily later. What's really important though is that you think carefully about what pattern is suitable for you to get the most representative sample that you can. Some patterns are more subject to bias than others, but choose a method and stick to it. The other really important thing is sampling depth, and this diagram has come directly out of the guide, and it represents how something like coal oil phosphorus can vary with depth down a soil profile, and various nutrients stratified by depth differently. So phosphorus might show this sort of behaviour, but potassium and sulphur may increase or decrease or bulge as they go down the profile. And if you're not taking a sample to the correct depth, that can have quite a big influence on the final result that you get in your soil sample, because you're taking a sample that's integrating that variation in nutrients down to the depth that has been specified. So if you're taking a sample that's slightly too shallow or slightly too deep, it's probably going to give you a small amount of variation in the actual value, because you're introducing a relatively small amount of something that has quite a low concentration. If, however, you do something like scuff the soil surface, you're kicking off potentially something that's quite nutrient enriched, and so you can actually have a significant influence on the final result. Equally, if you've got unconsolidated soils and you're using things like a pogo and lifting that out vertically, you can lose the bottom part of a core, and the numbers can change dramatically. So, you know, you need to be using equipment that can satisfy all of these challenges. What you find in the guide is some tables that show you by state of various crops and pasture systems and the recommended depths of sampling within each state for taking either surface or subsurface soil samples. And these are often based on calibration experiments that have been done in the likes of the Better Fertiliser Decisions for Pastures and cropping type programs. If you're faced with sampling in an area where there's previous fertiliser banding and there's quite a bit of detail and some equations and things to follow in the guide, but the general approach here is that if you can identify where the fertiliser bands are, you need to do some calculations to work out how many cores you need to take between the bands for each core that you take within the band. And that's all based on the band and row spacing, the diameter of the placed fertiliser, how mobile the nutrient is, and the core diameter that you're using to collect some samples. There's an example table that I've provided you here, but I'd send you to the guide to get more information about your approach there and the calculations you need to make. I just want to touch on, I guess, using soil sampling for other than agronomic reasons. So as we just mentioned in the last section, the depth of sampling for agronomic purposes is based on calibration experiments, and that's usually to the 0 to 10 centimetre layer because it represents the crop or pasture root environment where that crop or pasture is getting most of its nutrients. Can we use those same sort of soil tests for assessing things like environmental risk? So if we have some rainfall, is that rainfall interacting with the near surface, or is it interacting with the whole root zone? And so having an understanding of how the water or runoff interacts with the soil profile is really important to understanding that. So there has been a measure proposed called the Phosphorus Environmental Risk Index. It's a fairly simple ratio of the CoLP value divided by the phosphorus buffering index, and some tentative criteria have been developed for the use of that measure. We find some pretty good correlations between that risk index and the extraction of calcium chloride or soluble phosphorus out of those soil tests. But I just want to quickly go through an example here. So if we're taking a 0 to 10 centimetre soil sample, we might find that soil sample has a CoLP of say 54, a notional PBI of 100, and so we get a peri or phosphorus environmental risk index value of 0.54. So 54 divided by 100 gives us 0.54 as our risk. And we might conclude from that soil sample measured from 0 to 10 centimetres and using the tentative criteria that this particular site is not a risk at all. But when we consider that perhaps due to the stratification that something like 60% of that phosphorus is in the top 1 centimetre of the soil profile, and if we're faced with a situation where we have rainfall and surface runoff, it might be actually a much more fit for purpose approach if we took a 0 to 1 centimetre sample to determine what our environmental risk was. And if we did that in this particular case, we might end up with a peri value of 3.3 and actually identify this site as a risk. So sampling depth should be fit for purpose for the question you have in mind. So is that question an agronomic one, or is that question an environmental one? And the sampling should match that question. Jeff mentioned that collecting geocoordinates has become a really important part of the new Fertcare standards. And with smart devices, pretty much all of us are out there now with a mobile phone or some sort of tablet, and it's relatively straightforward, either using off-the-shelf packages or roll your own packages to collect geocoordinates. Provides confidence that we're following previous transects, collecting a representative sample, and that we're good to go with monitoring. It may also be useful from, I guess, a company perspective or from your own perspective to identify, systematic errors or unusual results. So I think it's a worthwhile thing to actually add to the standards. In terms of equipment to use, there's an array of equipment that is available. But what's important is that the equipment can provide you a representative sample. It answers the specific question that you're asking, that it suits the conditions that you have. So in some situations, some equipment is better suited to dry soil, some equipment is better suited to moist soils, some equipment is better suited to sampling shallow or deep. Some of you may face various occupational health and safety issues that you need to cover off on. So, that kind of dictates what sort of equipment you can use. The equipment may need to be rust resistant, account for things like contamination for trace metals, things like zinc and copper. So things like, galvanized iron buckets are out of the equation. Even things like sunscreens and white plastics can introduce contamination from zinc. Brass fittings, even studs on jeans can do things like introduce contamination from copper. The other really important thing for this equipment is that it's checked consistently for wear, that it's calibrated, and in some situations that equipment may need to be lubricated. Also things like, sampling, handling, dispatch and hygiene are really important. Cleaning tools, boots, vehicles, checking tyres, etc., moving between farms and possibly within the farm. Making use of on-farm washdown facilities where possible. Getting samples to the lab as quickly as you can. Don't post your samples late in the week because it's just going to sit in a post office somewhere or something like that. If you do have to store samples for a while, keep it away from heat, store it in a cool box, and check biosecurity requirements if you're having to send things interstate. So in terms of nutrient management and where's it going, increasingly we're seeing things like sensors being deployed, embedded chips. We're seeing dashboards of information being beamed to the cloud, and information readily accessible on your mobile phone. We're seeing things like drones and sensors, things like pasture readers, portable XRF, near infrared, whether that's benchtop or portable, test strips, etc. And it doesn't matter whether you're deploying a sensor or whether you're taking a soil sample. The whole activity is underpinned by good placement of that sensor or taking a good sample in the first place. If we don't get that right, then the rest is moot. So just in summary, we've covered off on some of the aspects here of the Fertcare Fit for Purpose soil sampling guide, which is aiming to improve consistency and accuracy across the industry. Hopefully we've demonstrated to you the importance of soil testing, being clear about your sampling purpose, collecting a representative sample that accounts for the variability that you might find, some of the sampling strategies and patterns that you might use in sampling a farm, collecting the right number of cores, and the guidance in the document here is to collect between 30 and 40 if you can. collecting the right depth, accounting for fertiliser banding issues, collecting geo coordinates. We've touched a bit on understanding some nutrient loss pathways and using soil testing to identify that, some of the sampling tools and some handling and hygiene aspects. So look, there's a lot more information in the guide itself, and if you haven't downloaded it yet, I'd urge you to get that either by way of the handouts section in your control panel or by going to the Fertcare website to get that. But look, I'll finish with that and hand back to Luke.
Thanks, Dave. Terrific. And we go to questions. And Abby, you've unmuted yourself. Thanks very much, Abby, for running the questions section. Abby is exactly the same job as myself, a development officer with the soils unit with New South Wales DPI, and it's right up in bushfire country up in northern New South Wales on the coast with smokes everywhere. But I'll hand over to you, Abby.
Okay, thanks, Luke. So if we start on the questions, Luke Hargraves has said, if paddock variability has been identified and mapped, then how many samples do you need per variable zone? Dave, do you want to answer that?
Okay, so it's pretty unusual to have actually mapped that variability, and the guidelines of around 30 to 40 cores take somewhat of a pragmatic approach, given that if you were to base your number of cores entirely on statistical theory, then there probably would be a lot less samples taken than there are now. So that's it gets really quite difficult if you based it entirely on the statistical theory. You could be taking hundreds of samples in order to account for that variability. So, you know, things like pH tend to be much less variable than things like phosphorus, potassium, or sulfur. But unfortunately, because you're taking a composite sample that's going to be analysed for a range of things, we need to account for what's the most variable analyte, and so it's a compromise between you know, matching the statistical theory and what's actually practical. You probably find that the 30 to 40 guideline is based on the poll that we had earlier is somewhat higher than probably we had as an indication from the early poll question. So what that's suggesting is to push the number of cores up from what is currently used out in the industry to cover off on more of that variability that's actually that actually exists. So I'm not sure if that answers the question. Certainly, if you know what the variability is already, then there are some statistical calculations that you can make in order to determine, you know, how many cores you need to be within a certain distance from the mean value with a certain level of confidence.
Patrick Francis has got a question that's about laboratories rather than sampling, I guess, and he says, how are soil lab fertiliser recommendations made? And because he gets frustrated by one lab giving different recommendations for nutrient levels, for example, from an Olsen P for different farms in the same district with the same grazing enterprise. And the question, I guess, is, are recommended levels based on soil science or on computer-generated models produced by the company doing the tests? So that's his question. Who wants to go have a go at that one?
I'll make a few comments. I'll make a few comments, and Dave, you can follow up, perhaps. Look, from a Fertcare perspective, and the nutrient decision support systems that engage with the Fertcare program and are assessed by Fertcare, the expectation is that those interpretations are based on accepted science in Australia. And part of the audit process for a Fertcare assessed system is where an independent auditor, currently Dr. Cameron Gooley, comes in and looks at the interpretation within that system. So in New Logic or Soilmate or Nutrient Advantage are some common examples of that. So it would be based on accepted science in Australia. Now there are obviously many more labs or nutrient people offering interpretation than that. Outside of that, you would need to consult directly with that laboratory about what is the basis for the interpretation of their results. But our view, Fertcare's view, would be that it should be based on accepted science within Australia. Dave, do you want to add any other comments?
No, look, I think you've covered that off pretty well, Jeff. And, you know, it just goes back to, as you say, the accepted science, peer-reviewed published information like better fertiliser decisions for crops and pastures. You know, those critical values and things are out there. BFDC also has a website which you can go and interrogate critical values for cropping enterprises. So yeah, it's very much around the accepted peer-reviewed science.
So I have another part to add to that, which I'm not quite sure if this is what Patrick wanted to know, but if you did have the situation where you have, you know, quite vastly different recommendations for the same sort of soil type, same issue, same enterprise, can you go to that lab and say, show me what you're using to get to that recommendation? So then you can then decide whether that lab is using the up-to-date science that they should be or not.
Sure. Look, I would encourage if there is some questions or uncertainty around what is the basis of the recommendation, by all means ask the organisation or the individual directly about that and ask them what is the basis of your recommendation. I think that would be a healthy thing to do, and they can point you then to what they use as their reference material and how that might or might not compare with those references that Dave talked about earlier, or 6 easy steps in the case of sugarcane, or there are other benchmarks for other industries. But asking that question is an entirely legitimate question to ask, I would think, of the individual directly involved.
Mm. Yep. Okay, thank you, Jeff. So the next question is from Shannon O'Brien, and Shannon has said, how many samples do you take if your auger is 6 centimetres in diameter? And there's another part to that question that is, what do you do if the ground is too hard to get the auger into the ground?
Yeah, okay. Again, if you go to the guide, there is a graphic in the guide that talks about the number of cores in relation to the diameter of your auger or corer. What needs to be said about that, though, is that a larger core will tend to account for more variability, and so therefore on that basis you could take fewer cores. What that doesn't mean is that you can go out into the middle of a paddock with a shovel and take a single block of soil out of the middle of the paddock, because you haven't accounted for the variability. So look, have a look at the guide and see what it says there in terms of the number of cores and the width of the corer. And I'm not sure if that diagram goes up to 6 centimetres. I think it only goes up to 5 centimetres. But to play it safe, even if you were taking a 6 centimetre core, I would still base it on the 5 centimetre core in the diagram in the guide. The other part of the question was, what if your soil's too hard to take a sample? And that is certainly a problem, particularly for cores or tubes. And, you know, there's a lot of bits of bent over pipe that are probably stuck in the ground out there in various paddocks where researchers or practitioners have been unable to extract the core after they've knocked it into the ground. But increasingly there are battery operated augers, which take around about a 25 millimetre core, and they're quite capable of going into hard setting soils. Often they'll have a tungsten tip bit on them as well, so they're pretty good in terms of not wearing that much.
Okay, thanks, Dave. Sam Adams has got the next question, and Sam says, when we have a paddock of varying soil types and history, each of equal area, how best do we sample? Do we sample what would be the least fertile area or the greater, assuming the client is budget conscious?
Well, it comes down to a conversation with the grower at the end of the day. And, you know, if they're budget conscious, I mean, if you've got 2 zones, then, you know, that's 2 soil samples, which in the scheme of things is not that expensive, probably compared to what they're going to spend on fertiliser. So I would, wherever possible, if they're faced with that situation where they're going to be either under fertilising or over fertilising half of that paddock, I would be urging the collection of 2 soil samples so that you could get through to the recommendation phase, because that provides the grower with much more information to make a decision, rather than just simply basing it on, you know, a soil test. I would be encouraging the grower to take as many soil samples as it takes to get through to that recommendation phase, because you're in a much better position to answer the questions given that the grower is budget conscious. If he's budget conscious about soil testing, then he probably should be budget conscious about his fertiliser program. So yeah, that needs to get through the recommendation stage, and I'd be coming up with several recommendations based on the different soil tests under that situation.
Yeah, good points. Thank you, Dave. And next is a question that I think lots of people probably were always asking or curious about. It's from Carl Anderson, and Carl has asked, could you comment on the persistence of the ideal soil ratios a la Albrecht versus sufficiency level of nutrients used when interpreting the same soil test results? And he said particularly around the excessive application of lime.
Yeah, look, ultimately we're looking for the evidence that would support a interpretation or a recommendation. So within a cropping enterprise or within a soil type for a region, if in Australia we've got quite a bit of work which has been done certainly for the major crops. So I would be using the local data where it's available.
That's all the questions that are in the question pane for what people have written. There was also one, and you may have covered it a little bit already, the two of you, but I know that Jeff was keen to point out at what was really necessary in terms of what Fertcare would like to see, about how people describe and document their sampling methods and techniques and the rationale for them. So did you want to say anything to that, Jeff?
Yeah, just to encourage particularly Fertcare accredited advisors, but other agronomists that are operating out there as well, just to describe the sampling approach that's used as part that the recommendation is actually based on, and provide a greater level of transparency about that. So what I'm meaning specifically is, you know, sampling depth has been commonly used, and we want to continue to see that nominated on the recommendation, what depth the sample was taken from, but also the sampling approach that was used. So what I mean by that is, was it a cluster sample? Was it a transect? Was it a grid sample? How did you go about sampling that particular paddock? And just a short comment about that as part of the recommendation. That's what we'll be looking for in the future and expecting that of Fertcare accredited advisors, but I think it just is good practice to get involved with. So I just want to reinforce that and encourage agronomists to consider that for the future, please.
Okay, thanks. And so it looks like that's all. I can't see any other questions. I'll just have a quick look in the chat panel to see if there's anything in there. So over to you, Luke. That's it, I think.
Yeah, thanks so much, Abby. Massive help on probably our biggest webinar. We had 250 people registered. Did we mention, or Jeff, did we talk people through how to find this online?
Very quickly, if you go to the Fertcare website, soils, what is it now? Soils and information. So it's Fertcare. I'm not sure whether people, I'm assuming people can see my screen.
Yep, yeah, we can see it.
Fertcare, nutrients and fertiliser information. If you go to that section, you'll see this first item there is the soil sampling guide, and you can download it from that link there.
And that takes you to a PDF version.
Yes. Yep. So if you click on that, you can directly go to the PDF version. You can save that PDF version, etc. So it's open for everyone to anyone who might want to access it. It's free to anyone.
Terrific, Jeff. All right, everybody. Thanks very much. Terrific webinar. See everybody.
Thank you.